Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your company stores a large number of audio files of phone calls made to your customer call center in an on-premises database. Each audio file is in WAV format and is approximately 5 minutes long. You need to analyze these audio files for customer sentiment. You plan to use the speech-to-text API. You want to use the most efficient approach. What should you do? The options are: Option A, 1. Upload the audio files to cloud storage. 2. Call the speech, long-running recognize API endpoint to generate transcriptions. 3. Call the predict method of an AutoML sentiment analysis model to analyze the transcriptions. Option B, 1. Upload the audio files to cloud storage. 2. Call the speech, long-running recognize API endpoint to generate transcriptions. 3. Create a cloud function that calls the natural language API by using the analyze sentiment method. Option C, 1. Iterate over your local files in Python. 2. Use the speech-to-text Python library to create a speech.recognition audio object and set the content to the audio file data. 3. Call the speech, recognize API endpoint to generate transcriptions. 4. Call the predict method of an AutoML sentiment analysis model to analyze the transcriptions. Option D, 1. Iterate over your local files in Python. 2. Use the speech-to-text Python library to create a speech.recognition audio object and set the content to the audio file data. 3. Call the speech, long-running recognize API endpoint to generate transcriptions. 4. Call the natural language API by using the analyze sentiment method.
To arrive at the correct answer, we focus on the keywords, audio files, approximately 5 minutes long, analyze these audio files for customer sentiment, speech-to-text API, most efficient approach.
The correct answer is option B, 1. Upload the audio files to cloud storage. 2. Call the speech, long-running recognize API endpoint to generate transcriptions. 3. Create a cloud function that calls the natural language API by using the analyze sentiment method.
Why is this correct? B. Uploading to cloud storage and using speech long-running recognize is required for audio over 1 minute. Using the natural language API analyze sentiment is the most efficient, pre-trained approach for sentiment analysis compared to building a custom AutoML model. Why are the others incorrect? A. AutoML sentiment analysis is less efficient because it requires providing custom training data, whereas the natural language API provides pre-trained sentiment analysis. C. Iterating over local files and sending content directly fails because audio longer than 1 minute requires uploading to cloud storage and using speech long-running recognize. AutoML is also less efficient. D. Passing audio data directly from local files to speech long-running recognize is not supported, it requires a cloud storage URI. Iterating locally is also less efficient.
You are an ML engineer at a regulated insurance company. You are asked to develop an insurance approval model that accepts or rejects insurance applications from potential customers. What factors should you consider before building the model? The options are: Option A, redaction, reproducibility, and explainability. Option B, traceability, reproducibility, and explainability. Option C, federated learning, reproducibility, and explainability. Option D, differential privacy, federated learning, and explainability.
To arrive at the correct answer, we focus on the keywords, regulated insurance company, insurance approval model, accepts or rejects.
The correct answer is option B, traceability, reproducibility, and explainability.
Why is this correct? B. In regulated industries like insurance, traceability of data and models, reproducibility of model training, and explainability of the model's decisions are critical for compliance, fairness, and auditing purposes. Why are the others incorrect? A. Redaction is the process of removing sensitive data from documents, which is a data pre-processing step, not a core governance factor like traceability. C. Federated learning is a technique for training models across decentralized edge devices, which is not specified as a requirement for this scenario. D. Differential privacy and federated learning are specialized privacy and distributed training techniques, not general compliance factors required for a standard regulated insurance model.
You work at a bank. You have a custom tabular ML model that was provided by the bank's vendor. The training data is not available due to its sensitivity. The model is packaged as a Vertex AI model serving container, which accepts a string as input for each prediction instance. In each string, the feature values are separated by commas. You want to deploy this model to production for online predictions and monitor the feature distribution over time with minimal effort. What should you do? The options are: Option A, 1. Upload the model to Vertex AI Model Registry and deploy the model to a Vertex AI endpoint. 2. Create a Vertex AI model monitoring job with feature drift detection as the monitoring objective, and provide an instance schema. Option B, 1. Upload the model to Vertex AI Model Registry and deploy the model to a Vertex AI endpoint. 2. Create a Vertex AI model monitoring job with feature skew detection as the monitoring objective, and provide an instance schema. Option C, 1. Refactor the serving container to accept key-value pairs as input format. 2. Upload the model to Vertex AI Model Registry and deploy the model to a Vertex AI endpoint. 3. Create a Vertex AI model monitoring job with feature drift detection as the monitoring objective. Option D, 1. Refactor the serving container to accept key-value pairs as input format. 2. Upload the model to Vertex AI Model Registry and deploy the model to a Vertex AI endpoint. 3. Create a Vertex AI model monitoring job with feature skew detection as the monitoring objective.
To arrive at the correct answer, we focus on the keywords. The training data is not available, accepts a string as input, monitor the feature distribution over time, minimal effort.
The correct answer is option A, 1. Upload the model to Vertex AI Model Registry and deploy the model to a Vertex AI endpoint. 2. Create a Vertex AI model monitoring job with feature drift detection as the monitoring objective, and provide an instance schema.
Why is this correct? A. Feature drift detection monitors serving feature distributions over time. Providing an instance schema allows Vertex AI to parse the string inputs without requiring container refactoring, satisfying the minimal effort requirement. Why are the others incorrect? B. Feature skew detection compares serving data against training data. Since training data is not available, skew detection cannot be used. C. Refactoring the serving container to accept key-value pairs requires modifying the vendor's container, violating the minimal effort requirement when an instance schema can simply be provided. D. Refactoring the container violates the minimal effort requirement, and skew detection cannot be performed without the training data.
You work for a bank with strict data governance requirements. You recently implemented a custom model to detect fraudulent transactions. You want your training code to download internal data by using an API endpoint hosted in your project's network. You need the data to be accessed in the most secure way, while mitigating the risk of data exfiltration. What should you do? The options are: Option A, enable VPC service controls for peerings, and add Vertex AI to a service perimeter. Option B, create a Cloud Run endpoint as a proxy to the data. Use Identity and Access Management (IAM) authentication to secure access to the endpoint from the training job. Option C, configure VPC peering with Vertex AI, and specify the network of the training job. Option D, download the data to a cloud storage bucket before calling the training job.
To arrive at the correct answer, we focus on the keywords: strict data governance requirements, API endpoint hosted in your project's network, accessed in the most secure way, mitigating the risk of data exfiltration.
The correct answer is option A. Enable VPC service controls for peerings, and add Vertex AI to a service perimeter.
Why is this correct? A. VPC service controls protect against data exfiltration by allowing you to define a security perimeter around Google Cloud resources like Vertex AI, mitigating data exfiltration risks while using private services access, peerings. Why are the others incorrect? B. Cloud Run with IAM doesn't explicitly protect against data exfiltration, as data can still be exported out of the network once retrieved by the training job. C. VPC peering alone provides network connectivity but lacks explicit controls to prevent data exfiltration out of the authorized networks. D. Moving data to cloud storage adds an unnecessary step, increases attack surface, and doesn't inherently prevent data exfiltration without additional controls like VPC service controls.
You want to rebuild your ML pipeline for structured data on Google Cloud. You are using PySpark to conduct data transformations at scale, but your pipelines are taking over 12 hours to run. To speed up development and pipeline runtime, you want to use a serverless tool and SQL syntax. You have already moved your raw data into cloud storage. How should you build the pipeline on Google Cloud while meeting the speed and processing requirements? The options are: Option A, use DataFusion's GUI to build the transformation pipelines, and then write the data into BigQuery. Option B, convert your PySpark into Spark SQL queries to transform the data, and then run your pipeline on Dataproc to write the data into BigQuery. Option C, ingest your data into Cloud SQL, convert your PySpark commands into SQL queries to transform the data, and then use federated queries from BigQuery for machine learning. Option D, ingest your data into BigQuery using BigQuery load, convert your PySpark commands into BigQuery SQL queries to transform the data, and then write the transformations to a new table.
To arrive at the correct answer, we focus on the keywords: structured data, serverless tool, SQL syntax, raw data into cloud storage.
The correct answer is option D. Ingest your data into BigQuery using BigQuery load, convert your PySpark commands into BigQuery SQL queries to transform the data, and then write the transformations to a new table.
Why is this correct? D. BigQuery is a fully managed, serverless data warehouse that natively supports SQL. Loading data from cloud storage into BigQuery and using BigQuery SQL for transformations perfectly meets the requirements for a serverless tool and SQL syntax. Why are the others incorrect? A. Cloud Datafusion uses a visual GUI for building pipelines, which violates the explicit requirement to use SQL syntax. B. Dataproc is a managed service for Spark and Hadoop, but it is not a serverless tool as it requires provisioning and managing clusters. C. Cloud SQL is designed for transactional (OLTP) workloads, not for processing large-scale analytical data transformations, making it inefficient for this pipeline.
You recently used XGBoost to train a model in Python that will be used for online serving. Your model prediction service will be called by a backend service implemented in Golang running on a Google Kubernetes Engine (GKE) cluster. Your model requires pre- and post-processing steps. You need to implement the processing steps so that they run at serving time. You want to minimize code changes and infrastructure maintenance, and deploy your model into production as quickly as possible. What should you do? The options are: Option A, use FastAPI to implement an HTTP server. Create a Docker image that runs your HTTP server, and deploy it on your organization's GKE cluster. Option B, use FastAPI to implement an HTTP server. Create a Docker image that runs your HTTP server, upload the image to Vertex AI model registry, and deploy it to a Vertex AI endpoint. Option C, use the predictor interface to implement a custom prediction routine. Build the custom container, upload the container to Vertex AI model registry, and deploy it to a Vertex AI endpoint. Option D. Use the XGBoost pre-built serving container when importing the trained model into Vertex AI. Deploy the model to a Vertex AI endpoint. Work with the backend engineers to implement the pre- and post-processing steps in the Golang backend service.
To arrive at the correct answer, we focus on the keywords: model requires pre- and post-processing steps, minimize code changes and infrastructure maintenance, deploy your model into production as quickly as possible.
The correct answer is option C. Use the predictor interface to implement a custom prediction routine. Build the custom container, upload the container to Vertex AI model registry and deploy it to a Vertex AI endpoint.
Why is this correct? C. Vertex AI Custom Prediction Routines, CPR, allow you to bundle Python pre/post-processing code with your model via the predictor interface. This avoids infrastructure management and cross-language rewrites, minimizing code changes and infrastructure maintenance for quick deployment. Why are the others incorrect? A. Deploying a custom fast API server on GKE requires managing the underlying infrastructure, autoscaling, and load balancing, which fails to minimize infrastructure maintenance. B. Building a custom fast API server from scratch requires more code changes and boilerplate than leveraging Vertex AI's custom prediction routines. D. Rewriting the Python pre- and post-processing steps in the Golang backend service requires significant code changes and delays deployment, violating the core requirements.
You have recently trained a scikit-learn model that you plan to deploy on Vertex AI. This model will support both online and batch prediction. You need to pre-process input data for model inference. You want to package the model for deployment while minimizing additional code. What should you do? The options are: Option A. 1. Upload your model to the Vertex AI model registry by using a pre-built scikit-team prediction container. Point 2. Deploy your model to Vertex AI endpoints and create a Vertex AI batch prediction job that uses the instance config.instance type setting to transform your input data. Option B. 1. Wrap your model in a custom prediction routine, CPR, and build a container image from the CPR local model. Point 2. Upload your scikit-learn model container to Vertex AI model registry. Point 3. Deploy your model to Vertex AI endpoints and create a Vertex AI batch prediction job. Option C. 1. Create a custom container for your scikit-learn model. Point 2. Define a custom serving function for your model. Point 3. Upload your model and custom container to Vertex AI model registry. Point 4. Deploy your model to Vertex AI endpoints and create a Vertex AI batch prediction job. And the remaining options are: Option D. 1. Create a custom container for your scikit-learn model. Point 2. Upload your model and custom container to Vertex AI model registry. Point 3. Deploy your model to Vertex AI endpoints and create a Vertex AI batch prediction job that uses the instance config.instance type setting to transform your input data.
To arrive at the correct answer, we focus on the keywords: scikit-learn model, deploy on Vertex AI, pre-process input data, minimizing additional code.
The correct answer is option B. 1. Wrap your model in a custom prediction routine, CPR, and build a container image from the CPR local model. Point 2. Upload your scikit-learn model container to Vertex AI model registry. Point 3. Deploy your model to Vertex AI endpoints and create a Vertex AI batch prediction job. Review the options on screen.
Why is this correct? B. Custom prediction routines, CPR, allow you to easily bundle data pre-processing logic with your scikit-learn model into a container, minimizing the additional code needed compared to building a fully custom container from scratch. Why are the others incorrect? A. The instance config.instance type setting specifies the compute hardware for the job, not data transformation logic. Pre-built containers alone cannot handle custom pre-processing. C. Building a completely custom container and defining a custom serving function requires writing and maintaining significantly more code than using Vertex AI CPR. D. Creating a full custom container requires more code than CPR, and instance config.instance type specifies compute resources rather than transforming input data.
You developed a custom model by using Vertex AI to forecast the sales of your company's products based on historical transactional data. You anticipate changes in the feature distributions and the correlations between the features in the near future. You also expect to receive a large volume of prediction requests. You plan to use Vertex AI model monitoring for drift detection and you want to minimize the cost. What should you do? The options are: Option A, use the features for monitoring. Set a monitoring frequency value that is higher than the default. Option B, use the features for monitoring. Set a prediction sampling rate value that is closer to 1 than 0. Option C, use the features and the feature attributions for monitoring. Set a monitoring frequency value that is lower than the default. Option D, use the features and the feature attributions for monitoring. Set a prediction sampling rate value that is closer to 0 than 1.
To arrive at the correct answer, we focus on the keywords, changes in the feature distributions, correlations between the features, large volume of prediction requests, minimize the cost.
The correct answer is option D, use the features and the feature attributions for monitoring. Set a prediction sampling rate value that is closer to 0 than 1.
Why is this correct? D. Monitoring feature attributions detects changes in feature correlations. With a large volume of requests, setting the prediction sampling rate close to 0 minimizes BigQuery logging and storage costs while maintaining drift detection. Why are the others incorrect? A. Omitting feature attributions misses correlation changes. Also, setting a higher monitoring frequency increases operational costs, which contradicts the goal of minimizing costs. B. This misses feature attribution monitoring needed for correlation changes. Additionally, a high sampling rate logs almost all requests, maximizing storage costs rather than minimizing them. C. While lowering monitoring frequency saves some compute cost, it does not reduce the substantial BigQuery logging costs caused by capturing a large volume of prediction requests without a reduced sampling rate.
You received a training serving skew alert from a Vertex AI model monitoring job running in production. You retrained the model with more recent training data and deployed it back to the Vertex AI endpoint, but you are still receiving the same alert. What should you do? The options are: Option A, update the model monitoring job to use a lower sampling rate. Option B, update the model monitoring job to use the more recent training data that was used to retrain the model. Option C, temporarily disable the alert. Enable the alert again after a sufficient amount of new production traffic has passed through the Vertex AI endpoint. Option D, temporarily disable the alert until the model can be retrained again on newer training data. Retrain the model again after a sufficient amount of new production traffic has passed through the Vertex AI endpoint.
To arrive at the correct answer, we focus on the keywords, training serving skew alert, Vertex AI model monitoring job, retrained the model with more recent training data, deployed it back to the Vertex AI endpoint, still receiving the same alert.
The correct answer is option B, update the model monitoring job to use the more recent training data that was used to retrain the model.
Why is this correct? B. The monitoring job compares production traffic against a baseline dataset. When the model is retrained on new data, the monitoring job must be updated with this new training data as its baseline to prevent false training serving skew alerts. Why are the others incorrect? A. Lowering the sampling rate only reduces the amount of production data analyzed, it does not resolve the mismatch between the production traffic and the outdated baseline dataset. C. Waiting for new traffic will not resolve the alert. The monitoring job will still compare the new production traffic against the old, outdated training baseline, triggering the same skew alert. D. The model has already been retrained. Waiting to retrain again ignores the actual problem, which is that the model monitoring job is still using the old training baseline for skew detection.
You are an ML researcher and are evaluating multiple deep learning-based model architectures and hyperparameter configurations. You need to implement a robust solution to track the progress of each model iteration, visualize key metrics, gain insights into model internals, and optimize training performance. You want your solution to have the most efficient and powerful approach to compare the models and have the strongest visualization abilities. How should you build this solution? The options are: Option A, use Vertex AI TensorBoard for in-depth visualization and analysis, and use BigQuery for experiment tracking and analysis. Option B, use Vertex AI TensorBoard for visualizing training progress and model behavior, and use Vertex AI Feature Store to store and manage experiment data for analysis and reproducibility. Option C, use Vertex AI Experiments for tracking iterations and comparison, and use Vertex AI TensorBoard for visualization and analysis of the training metrics and model architecture. Option D, use Vertex AI Experiments for tracking iterations and comparison, and use BigQuery and Looker Studio for visualization and analysis of the training metrics and model architecture.
To arrive at the correct answer, we focus on the keywords, evaluating multiple deep learning-based model architectures and hyperparameter configurations, track the progress of each model iteration, visualize key metrics, gain insights into model internals, compare the models.
The correct answer is option C, use Vertex AI Experiments for tracking iterations and comparison, and use Vertex AI TensorBoard for visualization and analysis of the training metrics and model architecture.
Why is this correct? C. Vertex AI Experiments is purposefully designed to track and compare model training iterations. Vertex AI TensorBoard provides the specialized visualization capabilities required to gain deep insights into deep learning metrics and model internals. Why are the others incorrect? A. BigQuery is a data warehouse and does not provide out-of-the-box, efficient ML experiment tracking and management capabilities like Vertex AI Experiments. B. Vertex AI Feature Store is meant for managing, sharing, and serving machine learning features, not for storing experiment tracking data or comparing model iterations. D. BigQuery and Looker Studio are generalized data and BI tools that lack specialized deep learning visualization features, like computation graphs, provided by TensorBoard.
You work for a gaming company that manages a popular online multiplayer game where teams with 6 players play against each other in 5-minute battles. There are many new players every day. You need to build a model that automatically assigns available players to teams in real time. User research indicates that the game is more enjoyable when battles have players with similar skill levels. Which business metrics should you track to measure your model's performance? The options are: Option A, average time players wait before being assigned to a team. Option B, precision and recall of assigning players to teams based on their predicted versus actual ability. Option C, user engagement is measured by the number of battles played daily per user. Option D, rate of return is measured by additional revenue generated minus the cost of developing a new model.
To arrive at the correct answer, we focus on the keywords, game is more enjoyable, business metrics.
The correct answer is option C, user engagement is measured by the number of battles played daily per user.
Why is this correct? C. User engagement directly translates the business goal of making the game more enjoyable into a measurable metric. If players enjoy the game more due to better matchmaking, they will play more battles daily, reflecting the model's success. Why are the others incorrect? A. Wait time measures system efficiency and matchmaking speed, not the business impact of enjoyable, balanced matches that the model aims to provide. B. Precision and recall are technical machine learning metrics used for model evaluation, not business metrics, and they do not directly measure player enjoyment. D. While ROI is a valid financial metric, it does not directly measure the stated primary business goal of making the game more enjoyable for the players.
You work for a gaming company that has millions of customers around the world. All games offer a chat feature that allows players to communicate with each other in real time. Messages can be typed in more than 20 languages and are translated in real time using the Cloud Translation API. You have been asked to build an ML system to moderate the chat in real time while assuring that the performance is uniform across the various languages and without changing the serving infrastructure. You trained your first model using an in-house Word 2vec model for embedding the chat messages translated by the Cloud Translation API. However, the model has significant differences in performance across the different languages. How should you improve it? The options are: Option A, add a regularization term such as the min-diff algorithm to the loss function. Option B, train a classifier using the chat messages in their original language. Option C, replace the in-house Word 2vec with GPT-3 or T5. Option D, remove moderation for languages for which the false positive rate is too high.
To arrive at the correct answer, we focus on the keywords. Performance is uniform across the various languages, without changing the serving infrastructure. Significant differences in performance across the different languages.
The correct answer is option B, train a classifier using the chat messages in their original language.
Why is this correct? B. Training on original language messages avoids information loss and inaccuracies introduced by translation. Since the system already receives the original messages, this approach improves performance uniformly across languages without requiring changes to the existing serving infrastructure. Why are the others incorrect? A. Min-diff is a fairness technique that aligns score distributions, but it does not address the fundamental issue of translation-induced information loss causing the performance disparity. C. Replacing the lightweight in-house Word 2vec model with massive models like GPT-3 or T5 would require substantial changes to the serving infrastructure, violating the given constraints. D. Removing moderation for certain languages ignores the requirement to moderate the chat uniformly and degrades the product's safety and user experience.
You are an ML engineer at a bank. You need to build a solution that provides transparent and understandable explanations for AI-driven decisions for loan approvals, credit limits, and interest rates. You want to build this system to require minimal operational overhead. What should you do? The options are: Option A, deploy the Learning Interpretability Tool, LIT, on App Engine to provide explainability and visualization of the output. Option B, use Vertex Explainable AI to generate feature attributions, and use feature-based explanations for your models. Option C, use AutoML tables with built-in explainability features, and use Shapley values for explainability. Option D, deploy pre-trained models from TensorFlow Hub to provide explainability using visualization tools.
To arrive at the correct answer, we focus on the keywords: transparent and understandable explanations, minimal operational overhead.
The correct answer is option B, use Vertex Explainable AI to generate feature attributions, and use feature-based explanations for your models.
Why is this correct? B. Vertex Explainable AI is a fully managed service that natively provides feature attributions and explainability, directly satisfying the requirement for minimal operational overhead. Why are the others incorrect? A. Deploying LIT on App Engine requires setting up and managing custom infrastructure, which violates the requirement for minimal operational overhead. C. AutoML Tables is a legacy product replaced by Vertex AI. Vertex Explainable AI is the standard, modern Google Cloud solution for this requirement. D. Pre-trained models from TensorFlow Hub do not natively include a managed explainability framework, requiring custom implementation and leading to high operational overhead.
You are an ML engineer at a global car manufacturer. You need to build an ML model to predict car sales in different cities around the world. Which features or feature crosses should you use to train city-specific relationships between car type and number of sales? The options are: Option A, the individual features, bind latitude, bind longitude, and one hot encoded car type. Option B, one feature obtained as an element-wise product between latitude, longitude, and car type. Option C, one feature obtained as an element-wise product between binned latitude, binned longitude, and one hot encoded car type. Option D, two feature crosses as an element-wise product, the first between binned latitude and one hot encoded car type, and the second between binned longitude and one hot encoded car type.
To arrive at the correct answer, we focus on the keywords: predict car sales in different cities, feature crosses, city-specific relationships between car type and number of sales.
The correct answer is option C, one feature obtained as an element-wise product between binned latitude, binned longitude, and one hot encoded car type.
Why is this correct? C. Binning latitude and longitude creates discrete grids representing specific areas like cities. Crossing these spatial bins with one hot encoded car types enables the model to effectively learn localized, city-specific relationships for car sales. Why are the others incorrect? A. Using individual features fails to capture the interactions between specific locations and car types. The model cannot learn localized patterns without explicit feature crosses. B. Raw continuous variables like latitude and longitude cannot be crossed effectively. They must be binned into discrete intervals first to define specific spatial regions. D. Crossing car types separately with latitude and longitude only captures one-dimensional spatial relationships, failing to identify precise two-dimensional intersections that represent specific cities.
You are training a TensorFlow model on a structured dataset with 100 billion records stored in several CSV files. You need to improve the input-output execution performance. What should you do? The options are: Option A, load the data into BigQuery and read the data from BigQuery. Option B, load the data into Cloud Bigtable and read the data from Bigtable. Option C, convert the CSV files into shards of TF records and store the data in cloud storage. Option D, convert the CSV files into shards of TF records and store the data in the Hadoop Distributed File System, HDFS.
To arrive at the correct answer, we focus on the keywords: training a TensorFlow model, 100 billion records, CSV files, improve the input-output execution performance.
The correct answer is option C, convert the CSV files into shards of TF records and store the data in cloud storage.
Why is this correct? C. TF record is TensorFlow's native binary format, optimized for high-throughput sequential I/O. Sharding TF records and storing them in cloud storage enables scalable, parallelized, and highly efficient data reading for model training on Google Cloud. Why are the others incorrect? A. Reading directly from BigQuery introduces I/O latency overhead and is not optimized for the high-throughput sequential reads required for TensorFlow training. B. Cloud Bigtable is designed for low-latency single-row operations, not for the bulk sequential data reading needed for training machine learning models. D. While HDFS is supported, cloud storage is the fully managed, native, and recommended storage service on Google Cloud, providing better integration and zero maintenance overhead.